Hey y'all, welcome to part one of a two-part mini-series I'm presenting on two-sided machining. Now, I've been waiting to do this for a long time and finally had the right project come up. Now, I got the idea for this project from a friend of mine on Facebook by the name of Robert Brown. He made a set of these jar lids for his wife, who makes candles in mason jars. Now, these are wooden lids that are pocketed out on the bottom side, and the metal rings from standard mason canning jars, 1-pint jars, are epoxied in down below. Now, you'll notice a little relief down here. I added this to the design because these lids have a rolled edge, and I wanted to be able to recess that lid in there all the way and not have that rolled edge exposed. These, you can see I have VCarved my wife's 4 favorite tea types and blends. And her favorites are Darjeeling, Earl Grey, regular black tea that you can find just about everywhere, and a specific brand that she likes to get sent to her from the UK. So I decided I would go ahead and try to cut these out for her. And it is a good demonstration of the double-sided machining technique. Let's go ahead and go into a new session of Aspire, and I'll show you how to do this. Now, even though I am using Aspire version 10, this project can also be done identically in VCarve Pro and VCarve Desktop. So, let's start out by creating a new file. Now, for this particular project, I'm going to be carving these lids out of a piece of material that I've been carrying around for probably 20 years. It's a piece of material that I got when we were stationed in Hawaii. The piece of material that I'm going to be using is basically irreplaceable. So, with that in mind, we'll go ahead and we'll design this project. Up here in Job Setup, this is a double-sided job. The width of this piece of material is 14¼ inches wide in X. It's 5½ inches high in Y. And after finishing planing and sanding, it is 0.7969 inches thick. For my Z0 position, here on a double-sided job, for both sides, I am going to be zeroing off of the material surface. I can either set my Z0 position on the material surface or the machine bed. But I have this option down here to zero off of the same side. Meaning, when I cut the first side, I'll be setting my Z0 to the top. Then when I flip it over to cut the second side, I'll be machining off of the machine bed. I don't want to do that. I want to set my Z0 off of the material surface on the top and on the bottom. Just keep your eyes on the little red circles here, because that shows you which corner you'll be setting your Z0 off of. My XY datum position for layout purposes is going to be the center of the material. Now, very important here, when we go to flip our material over after machining the top, are we going to flip it end for end sideways, or are we going to be flipping it top to bottom? That's very important for you to know that before you go any further, because that's going to dictate a few things within the design itself out here. Now, in my case, I'm going to be flipping it side for side. What that means is I'll machine the top of the top surface of the material. Then when I go to do the bottom, I'm going to flip this edge over to this edge. So that's very important to keep in mind. I do have one 3D model in this project, and I've set my modeling resolution to very high. We'll go ahead and click OK to accept that setup. Now, before we get into this really much at all, I'd like to show you a few things about double-sided machining. And that are these two icons right up here next to your layer manager. This icon here is to remind you that we're going to be flipping the material side for side, not top to bottom. It's real important to keep that in mind. Right next to it is a button. Toggle the top and bottom sides. If you look at this icon right now, you'll see the arrow is pointing down at the top of the material. If I click this button, the arrow is now pointing up to the bottom, and my scales have gone yellowish orange. That's letting me know that's a big visual indicator that I'm looking at the bottom of the material. To go back to the top, I'll just click on that icon again. The scales go back to their normal gray color, and the arrow's pointing down to the top of the material. It's very important to keep that in mind. To get the design started, something else that we're going to need to concern ourselves with, on my particular piece of material, I have some wane in the top edge right here when I mount the material on the machine. So I'm going to have to keep my designs down towards the bottom of the material. I need to stay an inch away from this edge. Something I'm going to do to remind myself of that is I'm going to use a guideline. I've not gotten into guidelines before, but they're actually very simple to use. To use a horizontal guideline, I'm going to put my cursor up here in the upper scale, click and hold down my left mouse button, and drag a guideline down right here on this edge. Now, that is indicated the top edge of my material. You'll see how my cursor has changed to up and down facing arrows. I want to right click over that guide, and that's going to give me these guide's properties. And it's showing me the position, showing me where I can move it to. I can lock it to prevent it from being moved, and I can create a new parallel guide. I can put it in an absolute position, or I can create a new one relative to this current guide right here. I'm going to create a new one 1 inch closer to 0, so it's a negative move. So I need to go negative 1 inch. Then I'll click Create New Guide. You see a new guideline down here as it appeared. I'll close. Any artwork I draw down here will have to be below this guideline. If your guidelines ever start getting in your way, you want to do something, because every time you get close to it, that cursor thinks you're over the guideline. If you want to move something and you're close to that, you can turn off these guides. The way you do that is come up here, and if you look in the corner where these two scales meet, this is a button to turn on and off your guidelines. So if I click that, my guidelines go away. If I click it again, they come back. So that's just something to remember if your guidelines are in the way. With all that being said, there's a couple of other things I need to remember. Number one, I'm going to screw this material down to the spoil board. So I need to stay away from the corners so I can mount some screws. Another thing to remember is I'm going to have to drill a pocket in the top surface of the material to put some indexing dowels, and I'm going to have to drill corresponding holes in my spoil board to put those dowels in to index when I flip this piece of material over. That will become a little bit more apparent as I get into the design, and you'll see what I mean. let's go ahead and draw 4 circles that are going to represent the 4 lids that I'm going to cut out. These will represent the outside profile of the finished piece. So we'll start by drawing some circles. The metal rings that make up the jar lids have a definite size, and I had to measure them up to see how big they were, then figure out how big to make these wooden jar lids. And I decided on a outside diameter of 3.3 inches. That's not too big, it's not too beefy, it's easy to get a hold of and be able to open up this jar. So I've got a 3.3 inch diameter selected, and I'm going to come down here and just click 4 times to draw 4 different lids. Now that's not where they're going to be cut. I'm just putting them there to get them on the material. Then I'll come over here and hit close. Now, as I said, I have to remember that I'm going to be putting a screw down here, so I want to make sure my bit doesn't run into that screw. So I'll select this first one, and we'll kind of move it up about over here. Now I can place a screw down here and my bit shouldn't hit it. Now I can move this one based on this position. And remember, I need to keep it below this guideline. Now something I need to remember is I need to remember that my bit has to pass through here. If I don't have a 1/4 inch of space between these circles, I'm going to have problems when it comes to cutting this outside profile. So I'm just using my cursor left and right buttons on my keyboard. I'll come in and kind of scoot these around a little bit to make sure that I have a 1/4 inch. There we go. And that looks okay. I'm well below my 1 inch mark. I'm back away from these corners so where I can drive a screw, and I've got enough space in between the circles that my bit should go through. Now I need to do something to make absolutely certain that I don't lose position when it comes to front and back. And that is, I'm going to select all 4 of these circles by drawing a box from right to left so that it touches all 4 to select them all. Then I'll right click right here, copy to other side. I need to do that so that when I flip over to the other side of my material, I have a visual reference as to where they are. Now you'll notice they moved. They changed position. That's because, if you remember, on the top side, this edge was over here. So if I go back to the top side, this circle right here is going to come over here and be right about there when I look at the bottom side. Okay? So I now have a visual representation of where that outside profile is on the bottom of my material. Now, from here, we also need to draw our locating dowels. Now, our locating dowels, what I'm going to do is I'm going to use 1/4 inch dowel, and I'll pocket on the top of the material, then cut a corresponding pocket into my spoil board. So I already know I want a 1/4 inch hole because I'm using 1/4 inch dowel. And I can safely put a pocket hole here, and I can put another one over here. These will be close enough to the edge that they'll help me to get the indexing right, but also far enough away from the screw or the path of the bit to where I won't cut into them. Now close, and then immediately select both, and again, copy those to the other side. So now, when I switch over to the bottom of my material, there are those corresponding index holes. These are the vectors I'm going to use to create the toolpath for the indexing holes I'm going to cut into the spoil board. The dowel holes on the top of the material will be cut into the material. Now, let's go ahead and do a little bit more design work. Something I want to do is I want to dish out the top of these lids just slightly, but I want a little bit of a flat edge out here. I don't want to just have the dish start right here where my profile is. So I'll need to offset to the inside on all four of these. So with all four selected, I'll come down here to Offset and Layout, and I want to offset inward by about 1/8 of an inch. So we'll go 0.125. I'm not going to create sharp corners. I don't want to delete the original, and I don't really care if the new ones are selected or not. We'll hit Offset, and I have 4 new vectors inside these outside profile circles. I can close that. Now, these do not need to be copied to the other side because this is just a design element that's going to be on the top of the jar lid. So now I want to select one of those vectors because I want to get the size. I want to know how big that vector is because that's how big I want to make my dish. So select one vector, come over here to Set Selected Object Size, and we see that it's 3.05 inches. So I'm going to go ahead and just copy that size. Just select it, hold down Control, and tap the letter C. And I'll close it. Now I want to add that dish. So I'll come down to my clip art, and I'll select my clip art library. I'll go down here to Domes and Dishes. Now I don't want it to be very deep or very steep. I don't want the sides to be steep. I just want a small dish. So I'm going to select this one, the 30-degree dish, and I'm going to double click it to put one right in the center of my material. Now I can resize this. So I'll come over into my Modeling tab, and with it selected, I'm going to select Set Selected Object Size. I'll click on that. Make sure I have Link XY checked. And I'll select that number in there. It doesn't matter if it's X or Y. They're both identical. Just backspace, hold down Control, and tap the letter V. And that puts that number, that measurement of this inside ring. Click Apply to resize. Now I can close that. With the model selected, click it again. You see how I go into Move and Transform mode. You see how my cursor changes to a crosshair? Just click and drag to drag this over, and we'll see it snap into the center right there. Now my model is centered inside this vector. And that's how we want it. But now if I look over here under my component tree, we notice it says Components Top. Again, we're working in the top of the material. The Combine mode is set to Merge Additive. I want a dish. I don't want a dome. So I'll right-click, go into Combine mode, change that to Subtract. The icon changes. We notice that the shading reversed itself. It went from being dark out here to dark in here. Now if I look at it in the 3D view, crank it up here a little bit, we can see that this is a dome, or excuse me, a dish rather than a dome. Go back to a straight Z view here. Go back into my 2D view. Now I want to check to see how deep that dish is. So I don't want it too deep. So with it still selected, I'll come up here and I'll click on this wrench to look at the model's properties. Okay, the shape height is pretty deep. I don't want it that deep. I'm going to just go ahead and change that to 0.1. That's going to be a very shallow dish. That's fine with me. That's how I prefer it. It did update. It did modify. I'll click close. And now we're all set. So now I need to make a copy to put into each one of these. The easy way to do that is to select it. Then I'm going to hold down the Control key. Now it's very hard to see because of the dark background here, but if you see my cursor, how it's the four-way arrow. When I get to the center, you see how it changes to that crosshair with the four-way arrow at the top right. Now I will click and drag. And this creates a copy that I can drag over here to the center of that vector, circle vector right there. And it just snaps into place. Let go of everything, and there we go. I've made a copy and snapped it into the center of this circle. Now I'll just do the same for these other two. Put my cursor over the center, hold down Control, click and drag, snap it into the center. Okay, let it update. Go to the center, hold Control, click and drag, snap it into the center, let go. And we see, whoops, it didn't copy, it drug it. That's okay. It moved it. I'll do that again. Find my bullseye there, hold down Control, click and drag. And there we go. So now I have a 3D model in each one. Each one is centered inside this inner vector here. Now if I go into my 3D view, take a look, all three are dishes, or all four are dishes, excuse me. And if I look over here on my component tree, they're all 0.1 inches high, and they're all subtractive instead of additive. I modified the first one, then when each copy was made, it copied the attributes of the first one. So there are my four models. Now I can go back over to my Drawing tab and I can add the text. What I'll do is I'll select this vector right here, just to the outside of the model. Then I'm going to come up here to Draw Text within a vector box. I'll click that and give it a second to load the fonts. Selecting Draw Text within a vector box, what it's going to do is it's going to automatically size the text to fit within that vector. So there are a lot of options that I don't have down here. I can't make the text larger or smaller here. I can stretch it a little bit vertically or horizontally, but I can't resize it here. I can't say I want half-inch tall letters. It will be automatically sized to fit everything within this vector box. And if you watch as I type, you'll see with each additional letter I type, the text gets a little bit shorter. I'm not going to check bold or italic. I want my text alignment in the center. The font I've chosen, I wanted a bold but simple font, so I chose a font called Biondi. B-I-O-N-D-I. And I'll come up here into my text box, and I'll start typing. I'll go into Caps Lock, and there's the first one. You notice as I type each letter, the text got shorter as the text string got longer. I'll show you again over here. I'm going to type Earl. You see how they got shorter? Now because this is two words, I want a hard break in between them. So I'll type enter, Earl Grey. Now I do want to resize that, but I'm not going to resize that here. We'll go on to the next one. Now I can click close, click off, and we see that all my text is centered off of the center character. In cases where we have 2 rows of 4, the center space is aligned. The same here. And where we have an odd number of letters, the center letter are aligned for both of them. I do want to resize the text here, make it a little bit smaller because that looks a little bit more bold than the other two. So let's just kind of tone that down a little bit. I've selected it, then select it again to go into Move and Transform mode. I'm going to hold down Shift, come over here to one of these corners and just bump that in just a little bit. I just want to reduce the size a little bit. And then we'll do the same thing over here. Select once, twice to go into Move and Transform mode. Come over to one of these corner boxes, hold down Shift to lock it to adjust from the center, and we'll bring that down some. There we go. Those are all of the vectors needed for the top of this project. Now I'm going to go ahead and save the project because I've done a lot of work and I don't want to lose it should the power go out or something foolish like that happen. So I'll go File, Save As, navigate to the correct folder rather. Save. Okay. Now I can go to work on the back side or the bottom side of this piece of material. Again, it's reminding me here we're flipping from side to side. So now I'll go over here and I'll click the bottom side of the project. Now before I start drawing, if we look, we can see the vectors on the other side of the material real faintly here in blue. That's to give us some frame of reference that allows us to see where things are on the other side of the material so we don't get completely lost and throw things out of alignment. I don't really have that problem, but it very well could happen. So just know that you've got a reference here. When I bought the jars with lids and rings to use for this project, I got out my calipers and I started measuring. And the rings have a definite outside diameter. Plus, they have a small rolled lip at the bottom. I need to make a little bit of an allowance for that lip around here without cutting out the entire pocket to that diameter, which would make it a real sloppy fit for the rest of that ring. I need to go ahead and make circles in here that are those diameters. So I'll show you what I mean in just a second. The actual lip pocket that I'm going to be cutting to recess that lip in is a circle with a 2.875 inch diameter. Now I'm going to bring my cursor down here and I'm going to go right for the center of this circle here. I'll bring it down here and you'll see how right there my cursor turns into a set of crosshairs. I can just click and a circle of that size is put right in the middle of this circle. That's right where I want it. So it come up and it does the same here. Click. Come up and it does the same here. Click. Click. So now I have my first vector placed inside my outside profile. Now I need to enter a vector for the actual pocket for this ring itself. I'll close that to make sure I can click off Otherwise, I would be changing the diameter of that ring. So we'll go back to create a circle. If I were to change this radius here, or this diameter here, with any of these vectors selected, it would change the diameter of that vector, which is what I didn't want to do. So now I need to come up here and I need to create vectors with a diameter of 2.736 inches. And again, come down, wait for that cursor to turn into the set of crosshairs, click. Now I can close those. These are all the vectors needed to cut this project. I can now go ahead and calculate toolpaths. So to do that, first we'll go back over to the top of the material. I'm going to hide my guidelines so they're no longer in the way. Then I'll switch over to my Toolpaths tab. Now is when I want to go into Material Setup right here by clicking the Set button. And I want to change my XY datum position to the bottom left because that's where I set the X, Y, and Z 0 outside on my CNC machine. None of the rest of this is going to change. That's all the same. I'll click OK. Now I want to go ahead and save this again. Just to save the file, make sure I don't lose anything. With that finished saving, the first thing I want to cut in this entire model is I want to cut these indexing holes for the dowels. And I'll do that with a pocket toolpath. So, click on the pocket toolpath. I want my start depth to be 0. I want to start on the surface of the material. And I want my cut depth to be a 1/2 inch, 0.5. I'm going to select the tool. I'm going to make sure I'm in my hardwood material because that's what this is. And I'm going to select 1/4 inch end mill. All of my parameters here are the way I want them. I'll select it. It's going to take 4 passes. That's fine. Now, a word of warning. I'm cutting a 1/4 inch diameter pocket using a 1/4 inch diameter bit. I have to remember to use an upcut bit for these 2 holes here. The reason is because with this drilling straight down into it, there is no clearance for those chips to go anywhere. I have to use an upcut bit to eject those chips up out of the material. If I use a downcut bit, I run a serious risk. With nowhere for those chips to go, and the bit forcing those chips down, friction can and will start a fire. I don't say this because I know somebody who has a friend who thought he heard of somebody who did it. I say this because I did it. I know firsthand. I started a fire, not knowing any better, drilling straight down with a downcut bit. Don't do it. Use an upcut bit. You want to eject those chips up out of that hole while the bit is plunging down and cutting. So, that being said, I want to clear the pocket using an offset strategy, and I'm going to ramp in the plunge moves. You might be asking yourself, why? Well, ramping in the plunge moves on this small of a hole to be drilled kind of slows down the plunge rate and gives it time for those chips to evacuate. So, we'll call this dowel holes, and we'll calculate. That's going to stay on top because that'll be the first toolpath I cut. I'll uncheck it, close my preview, and I'll just save up and we'll preview the whole thing all at once. Now the next thing I want to cut is I want to carve these 3D dishes. So I'll select the first one and hold down Shift, come along and select all 4 of the models. Then still holding down Shift, I'll come back and I'll select the 4 vectors right here, just outside of the model. This model is shallow enough I don't need to do a roughing toolpath. I'll go ahead and select 3D finishing. And I'm going to select my bit and make sure I've got my hardwood material loaded. And I'm going to use a 1/8 inch tapered ball nose. Select. For my machine limit boundary, I'm going to carve to the selected vector, meaning it will not carve outside of this vector. It's not going to come back up and try to carve out here at all. I'm going to use a raster strategy. Raster angle of 0, meaning it's going to go back and forth left to right with the grain of my piece of material. And I'm going to go ahead and just leave this named 3D Finishing 1. It's the only 3D model in the entire design. We'll calculate. Again, I'm just going to deselect it, and we'll preview them all at once, one after another when I get them all finished. Close my preview, go back to my 2D view, and now I want to VCarve my text. So I'll come along, I'll select this one, hold down Shift, select the rest, and I'll come up here to VCarve. I'm not going to enter anything for start depth or flat depth. I'm going to select my V-bit, which is a 1/2 inch diameter 60-degree V-bit. Make sure I'm in my hardwood material, and select. The reason I'm not going to put in a flat depth or a start depth or anything up here is because I'm going to come down here and make sure I have a check mark into project toolpath onto 3D model. That makes the software look at where this dish is and calculate where to start and how deep to cut by itself. I don't need to put anything in here. I can just leave it alone. It will project this text down onto the model and start cutting there. I'm not going to worry about anything here other than to change the name to VCarve text. We'll calculate that. Looks good so far. I will uncheck that, but I will come up here and change the toolpath color on that V-carving to black, just so we can see it when I do preview it. We'll go back to my 2D view. Now there's 2 more toolpaths to create for this side. I'll select the outside vectors here. Close my preview. I want to put a chamfer on the edge of these lids. So with the vector selected, I'll come here to Profile Toolpath, and I'm going to cut it, let's say 0.125. I'm going to go ahead and, 0.125, not 125 inches. That would be a trick. I want to see that. I'm going to select, make sure I've got the hardwood material here, and I'm going to use that same 60-degree V-bit. It's going to do it in one pass. That's fine. I want to make sure I do it on the vector. So it's going to follow that line specifically. I'm not going to change anything else down here. I will add ramps to the toolpath just because it tends to reduce any kind of a witness mark where the bit plunges in, and we'll ramp it in over a distance of 2 inches. And I will call that the profile chamfer. Calculate it. And those are the only toolpaths I'm going to calculate for the top of this material. So now we can go ahead and go down the list and preview all of these toolpaths. We'll start with the dowel holes. that's going to index the part when we flip the material over. We can move on now to the 3D finish. Then VCarve the text. Then do our profile chamfer. And there we go. That is the top of the material. Now we'll take the material off of the table, flip it over, and then cut the other side. But before we can do that, we need to calculate some toolpaths. So we'll flip over to the bottom, go into the 2D view, and the first thing I want to do is carve this little recess up here on the top for that rolled lip. So I'll select that outside, that center vector there. Have all four selected, close my preview, and I'm going to do a profile toolpath. Now the cutting depth for this is going to be a 1/16 of an inch deep. So I'll go 0.0625. I'm going to select a 1/4 inch end mill. Make sure I'm in hardwood material. 1/4 inch end mill. Select that. I want to machine to the inside of that vector. I want to cut this side of the vector. I don't need to do a separate last pass, no tabs. I don't need to ramp this in. I'm just going to call this the lid rim profile. And we'll calculate that. And there's our first toolpath for this side. Again, I'll uncheck it. We'll preview them all at once. Now I need to do the main pocket. So we'll select the inside vector on all four of these. Close my preview. Do a pocket toolpath. Now here, because I'm cutting out a large area, I can use an upcut or a downcut because there's some place for those chips to go. The only time I have to worry about upcut versus downcut is if I'm cutting something that's the same size as the bit I'm using. I've measured the thickness of these rims, and I need to pocket this out 19/32 of an inch deep. So I'll come up here to my cut depth, highlight everything in there, and we go 19/32. Then I'll tap the equals button, and there's my decimal equivalent to 19/32 of an inch. I've got my bit selected. Let's make sure I'm in my hardwood material. Yes, I am. 1/4 inch end mill. Select that. I'm not going to bother with a larger area clearance tool. Because I'm carving out a circle, I will go ahead and use an offset pocketing strategy. I'm not going to worry about a pocket allowance, but I am going to plunge in the ramp moves over a distance of an inch. And we'll call that the ring pocket, and we'll calculate that toolpath. And looks good so far. Again, I'll uncheck that, close my preview, go back over to my 2D view, and now I'm ready for my outside profile. So, holding down Shift, I'll select all four of these, and we'll do profile. I'm going to use a cut depth 0.005 of an inch deeper than my material is thick. So I'll type Z plus 0.005, then tap the equals button, and it gives me my cutting depth. I'm going to check my bit to make sure that I'm in the hardwood database. There it is. And I'm going to cut to the outside of those vectors. I'm not going to do a separate last pass, mainly because I'm concerned with the space in between them. And if I select a separate last pass, it may not allow it may not calculate the toolpath. I am, however, going to add tabs. Now, when we cut the other side, when we made that little chamfer around here, we removed about 1/8 of an inch of material. So I'm going to need to account for that 1/8 of an inch of material. So I'll need to make my tabs a little bit thicker than normal. So if I add 1/8 of an inch to 1/4 of an inch, I get 3/8 of an inch. So I'll change that to 375. And I'll show you what I mean a little bit later on when we preview these. I'll go ahead and edit the tabs. I'll put one at the top and bottom of each one of the rings. There we go. I'll close that. I am going to ramp in over a distance of 2 inches, a smooth ramp, and we'll call this profile cutout. It's warning me that the tool's going to cut all the way through the material. And there is my finished toolpath. So, with this done, I can now preview all of these to make sure that they work. We'll start with the profile lid rim. We'll preview that toolpath. That made that little recess for that rolled edge of the ring. Come down here and we'll pocket out there we go. Now I know that the ring, that lid ring, will sit all the way down inside the material. Then our profile cutout. We'll preview that toolpath. And here we see what I mean. Looking at it from the top, that tab didn't do me any good. So I'm going to have to come along and change that over to here. I'll remember that. So we'll flip this over and we'll look. This is why I made those tabs so thick. You'll see the V-bit removed some of that material before the tab got created. That's why I had to increase the thickness for that V-bit, carving that chamfer. So let me go back to a straight Z view, and I know that on this lid right here I need to move my tab over this direction. So I'll undo last, which should remove that. I'll go back over here into my profile cutout. I'll go to Edit Tabs, and this tab right here I'm going to move over here. I might put another one over here just for giggles, just to make sure. Now I can close, recalculate. Yes, I know it'll cut through the material. Now let's preview that toolpath. That's better. Now I know that's not going to go anywhere. Okay, we are all set, except for one more toolpath. This toolpath is going to be calculated on the bottom of the material, but it doesn't actually get cut into the bottom of the material. And that is these two dowel holes right here. We're going to go ahead and pocket them, make them a 1/2 inch deep using the 1/4 inch end mill. I'm not going to use a large area clearance tool. I'll use offset. I will ramp in the plunge moves. And we're going to call this dowel holes caps lock cut in table. Caps lock to come out. Now I'll calculate the toolpath. This toolpath here is cut into the spoil board. That's going to be for our registration holes for our index pins. Now I can go ahead and preview this if you want, and that will it'll drill all the way through fine. But they're not actually going to be cut into the material. They're going to be cut into the spoil board. Those are the toolpaths. This is the toolpathing portion of a double-sided job. Now I can reset the preview. I'm still looking at the bottom. I'll go back up to the top. We'll go for a straight Z view. And you may have noticed an additional button we have over here in the preview. And that is to preview all sides. We've always had preview all toolpaths, and it'll run all the toolpaths in order. But preview all sides previews all of the toolpaths for both sides of the material. Let's go ahead and click that and see what it looks like. It ran through all of the top toolpaths first, then it ran through all of the bottom toolpaths second. That gives us a good idea as to what this project is going to look like after everything is all said and done. Now the only thing that remains is for me to save Gcode, and I'll do that by first making sure I have my thumb drive in my computer, and I do. Now you'll notice I have created a folder for my flash drive titled T-Lids, and within that folder I have bottom and top. It lists them alphabetically. What can I say? So I'll go back over here into Aspire, and we're cutting the top first. So the first thing I want to do, because I don't have any other toolpaths that are going to use that 1/4" end mill, is I'll select dowel holes, come up here to save toolpath, and I'm going to output, there's only one visible toolpath. I've got my post processor selected. I just want to make sure that I have the right toolpath selected. I'll hit Save Toolpath. I'll navigate to that folder, and this is in the top. I want to make sure I remember that. This is the top, and I will save this. I'm going to add some more information here. 0.25 inch upcut end mill. Then I'll save that. My 3D Finish toolpath, I can now uncheck this. Check the 3D Finishing toolpath. Uses my 1/8 inch tapered ball nose. Save. 3D Finish, that's fine. 0.125 inch TBN for tapered ball nose. Save. I can uncheck that. Now I can check both the VCarve text and the profile chamfer because they both use the same bit. This will combine these toolpaths into one piece of Gcode. And I'll save. Notice I said combine, not merge. Different process, but that's for another video. And we'll type in 60° V-bit VCarve text. I'm going to go ahead, and even though it does do the profile, I will know that when it's finished. We'll save. Those are the toolpaths saved for the top. Now I'm going to deselect all of those. We'll change over to the bottom. And we're going to do dowel holes first. I will save that toolpath. Dowel holes cut in table. Save toolpath. I'll want to go to the bottom folder, 0.25 inch upcut and mill. I'll save this by itself. The minute I take the material off of the table to flip it, this will be the first toolpath I run. So now I can turn that one off. Now I can do the lid rim, the ring pocket, and the profile cutout, since they all use the same bit. And I'll save that toolpath. And we'll go call this 0.25 inch end mill caps lock all tool paths. And we'll save that. Close. Uncheck all of these, and now if I go into my T-Lids folder on my thumb drive, I have my bottom toolpaths, or Gcode rather, and the top Gcode. I'm ready to unplug this thumb drive from my computer, take it outside, and start cutting. And that's where we're going to leave this video. This is such a long subject, I'm going to break up into 2 parts. And in the next video, we will go ahead outside. I'll fasten my piece of material down to my spoil board. We'll set everything up. We'll cut the project to include these index dowel holes. So, I hope you got something out of this video. I know it was pretty long, and I hope it isn't real confusing. If I could give a piece of free advice, it would be to pick a couple of simple projects for your first double-sided machining project. Pick a couple of simple things. Keep in mind which way you're going to flip your material. Also keep in mind whatever you do on one side may affect the other. So when it comes to something like a chamfer and tabs, you'll need to make up for how much material is removed here in this chamfer by adding that thickness to your tabs. Again, I hope you got something out of this video. If you did, I hope you'll give me a thumbs up. And if you're not subscribed to my channel, I invite you to subscribe right now. I will be doing a live Q&A session on this subject of double-sided machining, anything I've covered in this video. That live Q&A session will start at noon Pacific, 3 p.m. Eastern, today on my YouTube channel. So if you're not subscribed, now's the perfect time to do so. And click that little notification bell so that you'll get a notification when I go live for a Q&A session on the topic presented in the video. So that's going to wrap up this video, and as always, whether you subscribe to my channel or not, I'd like to thank you very much for taking the time to watch, and y'all take care.